We all know how to solve this problem. We know that, well, there's a 6, there's an 8. Most of us can just know that it's 10 feet. But how would we do this formally? We'd use that a squared plus b squared equals c squared. And so 36 plus 64 equals 100, which is equal to c squared. And so c equals 10. That's how we find the hypotenuse of a right triangle. What we just used here is the Pythagorean theorem, that a squared plus b squared equals c squared. It's something that we've all memorized since childhood. But other than memory, how do we know that it's actually true? In this video, I'm going to prove the Pythagorean theorem. And so first, just consider this figure where we have an arbitrary right triangle sort of copy-pasted in these 4 different spots, and each is going to be rotated sort of 90 degrees to its counterpart. And so we know that this is C, and all these 4 sides are C. We know the middle figure right here, this figure within the white, is a rhombus at least. And I want to prove that first it's a square. And that's going to be really useful when later on I prove the Pythagorean theorem. So in order to prove that this is a square, I need to prove that these angles of these are exactly 90 degrees. And to do that, I'm going to use a technique called angle chasing. So consider this angle alpha, and I'm going to call this angle beta, and using just that fact that the angles of a triangle sum to 180 degrees, we can find that alpha plus beta plus 90 has to equal 180. And so alpha plus beta has to equal 90. And we also know that this is alpha, this is beta, this is alpha, this is beta, this is alpha, and this is beta, since we just sort of copy-pasted this triangle in 4 different spots, so the angles are also going to be the same. Now consider this straight line right here. We know that something on a straight line has to have angles that sum to 180 degrees. And so using that, we know that beta plus alpha plus this angle right here that I'm going to call gamma sub 1. So gamma sub 1 has to equal 180 degrees. And so subtracting this, we know that beta plus alpha is 90 and plus gamma 1 equals 180. Subtracting from both sides, we have that gamma sub 1 is exactly equal to 90 degrees. So we know that this is a right angle. And by similar logic, if we call this gamma sub 2, this gamma sub 3, this gamma sub 4, we can do the exact same thing. Instead of the gamma sub 1, we would just have gamma sub 2, 3, or 4, and we'd all end up with that it's going to be exactly 90 degrees. And so now we've proved that this middle figure right here is a square. So using that, we're going to prove the Pythagorean theorem by counting the area of this larger red square. So the area of this larger red square, just looking at the side length, is a plus b squared. And I'm going to expand this, so this is a squared plus 2ab plus b squared. But we can also count this by looking at the areas of these triangles and then adding the area of the square. So there's 4 triangles, and then times the area of a triangle is just 1/2 times AB, and then plus the area of the square, which has side length c, so it's plus c squared, which is also equal to the area. And so, well, this is equal to the area, this expression is also equal to the area, so you can set them equal. These are just 2 different ways to count the area. Now we're going to do some simplification. 2ab plus c squared equals a squared plus 2ab plus b squared. And now we can subtract 2ab from both sides, which gives that c squared equals a squared plus b squared, which proves that for any general right triangle right here, for the side lengths a, b, and c labeled like this, c squared is exactly equal to a squared plus b squared. Now this is just one of the possible 370 known proofs of the Pythagorean theorem. And if you're interested in things like these and actually wanting to understand math, check out my math book I wrote about math proofs. The link is in description. And as always, stay curious.